In this video, we'll be doing the question you see on the screen from the 2023 Leaving Cert Higher Level Maths Paper 1. If you're looking for a different question from this paper, there should be a playlist in the description below. And if you're looking for a different paper entirely, have a look on my channel. I'll be doing all of this on a whiteboard, hopefully just like you're used to your teacher doing. But remember, we are on YouTube, so take advantage of that. Pause, try the question first, and even change the speed of the video to half speed or 2x speed if that's your thing. If you find this video or any of my videos useful, I would greatly appreciate a like, a subscribe, or especially sharing it with someone else you think might help. It might help. Question 8 starts off with part A, and it's relatively straightforward. They tell us Olga has €3,000 and she puts this into a savings account at a 2.4% rate. It earns interest, it adds interest annually, so after every year it adds interest in, and this is in here for 5 years, how much money she has. There is a very quick formula just to work that out. Just let me do it a little slower though. Really, we'd have, after year one, at the start of year one, we'd have 3,000. At the end of the year, we'd have 2.4% of that, which would be, I believe, €72. So at the end of this, we'd have €3,000.72. And then next year, we would earn interest on this. So we would need to get 2.4% of this and add that on. And we'd have to do that 5 times. So you don't want to have to, it's not too hard to do 5 times, but you don't want to have to do it 100 or 1,000 times. So the quicker way is we'd start with 3,000. And what we're really multiplying by is this, and then adding itself on. And how we do that is multiply by 1, that just gets 3,000 again, and then add on 2.4%. Now, 2.4% is the same as 0.024. These numbers are the same. So if we add this on to 1, we get 1.024. This would tell us how much money we have after 1 year. And then if we multiply this again for year 2, this would tell us how much money, because this now becomes how much money we have at the end of year 1. And we stay doing this 5 times. This number just gets multiplied on 5 times. And really what that looks like is 3,000 multiplied by 1.024 to the power of 5. We put all that into a calculator and it would tell us the actual answer of €3,377.70. For the next part, part B, part 1, it's an English question really. They want your answer in English. Explain what is meant by present value of a payment of €1,000 in 1 year's time. So let me talk about it first, then I'd write down what my answer would be. Having money now is worth more than having money in the future. Hopefully that's fairly common sense. If I offered you €1,000 today or €1,000 a year from now, which would you take? You'd take it today, because it's literally worth more today. And that's because you could take that 1,000, put it in a bank, just like this person did with 3,000, and you would have more at the end of it. So it's money's worth more today than in the future. So if you know you're going to have to pay something in the future, it has a present value that's smaller than it, and that's less today. So the answer I would write for this is, let's see, explain what is meant by present value. Present value is how much, I'll edit this out, it's how much I need now to have 1,000 in a year. I guess with a given interest rate, given a certain interest rate. Part 2 of B is really, it's very similar to part A, just working a little backwards. They tell us this person, Chen, has a savings account, and after 6 years, their final number down here was 4,000. They had the same interest rate, and it was after 6 years. How much did they start with? So we just need to think of this question here, this line here, and work backwards. We don't know the starting amount, so we'd usually write X in for that, or P often, X. We know the interest rates. It's the same interest rate. So this is multiplied by 1.024 to the power of 6 this time. And we know the answer. The answer equals 4,000. So we just work this question backwards. Divide this term across. X is equal 4,000 divided by 1.024 to the power of 6. Put all that into your calculator and you'll get 3,469.45 cent. So that's it to B part 2. In part C we have a woman called Fiona, and she's the same interest rate of 2.4%, but she makes quarterly payments. And that means the interest rate's not the same. This is well, I guess it is the same, but this is over a year. We want to know what it is over a quarter of the year. And it's not as easy as just dividing this by 4. They want us to work out that quarterly interest rate. So again, we can't just divide it by 4. If you want, you could try that. Dividing this by 4 would be, I guess, 0.8%. Just let me put an X beside it so we know it's wrong. And doing a similar question, well, just 4 times over a year, some principal amount, 100, let's say, multiplied by 1.008. That's what this number is when added to 1 to the power of 4. Let's leave out the 100, just assume that's a 1. This does not equal 1.024. So 0.8, doing this 4 times a year would not get you to 2.4. I don't know what this is. Yeah, I haven't wrote it down anywhere, but this wouldn't get you to this number. What this question is really asking is, what number here would get you to this number, doing it 4 times a year? So that's relatively simple to solve. We can just put a big X here. X to the power of 4 is equal to 1.024. There's a slight different way to do this, so I'll do it in a moment. What is X? X is equal to 1.024 to the power of 1 over 4. If we take the 1 over 4 of both sides, this 4 disappears and this one appears here. And this would end up giving us 1.0059467. It would give us this number. Now they were looking for a percentage number. We have to be careful here. We need to find the percentage in this. It's not 1%. It's not 100%. It's actually what we see here. It's the answer here would be 0.59. And did they ask 2 decimal places? 0.59 then. This would be the answer here. So you need to be careful if you want to deal, and it's the easiest way to deal in percentages, especially in finance and stuff. If you want to deal with percentages that look like this, 1 point something, you have to be careful getting the answer out. Another way you might see this answer from this line here, what was going in here, this to the power of x, you might see it written as 1 plus I to the power of 4 is equal 1.024. Or you might see it being equal to 1 plus 2.4% or something like that. This would just be an extra step or 2 to solve. You should still get the same answer. Also, instead of this, you sometimes see 1 plus or over 100. So 2.4% divided by 100 is 0.24. But personally, I rather just dealing with this simpler term. It saves a lot of steps. And honours level student, you should be able to take this number out as a percent. Let me get rid of these brackets because hopefully that might be confusing at this point. You should be able to take a percentage out of this number. Okay, hopefully I didn't confuse you there. That's just how I do it. Anyway, let me clean this off when we do part D. Okay, for part D, they tell us a story about Rowan who puts the same amount of money in his savings accounts every month. So we're talking maybe he gets paid a couple of €1,000 a month, and he puts a couple of hundred every month into this saving thing. That's the sort of world we're in. We just don't know that number yet. He does this for 3 years, that's 36 months, and at the end of it all, we know he has a 12,000 euro. And they help us out and they tell us the interest every month is, let's write that bit down, 0.11%. That's quite small interest. If we put that to the power of 12, or add 1 to it first, put it to the power of 12, it would probably only be like around 2%. So it's not a high interest rate. And we also know the final answer, like I said, is 12,000. Okay, taking all this information and taking the idea that A is the amount of money he puts into his account at the start of the first month, find a geometric series for the amount of money after 3 years. Okay, right. You might have to read that a couple of times. Hopefully what I do now will explain it a bit more. Let's split the world into 36 parts. I might even double that actually. I'll say the first month, the start of the first month we'll talk about. He puts A into his account. So that maybe it's €100, maybe it's €1,000. It's some set number every month. At the end of the first month, he gets interest. So let's see, end of the first month. We won't do this for everyone. At the end of the first month, they give him interest, and that's A multiplied by 1.0011. That's 0.11%, and he gets to keep the original amount. This is how we increase numbers with interest, as we've already done in this question. So this is the end of the first month. The same happens, the start of the next month is this same number. The end of the second one, we'll just leave it at 2 for now, because the start of 2 is the same as this. The end of 2, he has this number in his account. Well, actually, yeah, let's put in the start of 2. Because he adds in a new amount, doesn't he? Sorry, my bad. 1.0011. He has this number and he adds in another amount. Oh, by the way, there is a formula for this in your formula book. So this is not something you have to figure out every time. The examiner just wants you to do it this way. That's why they're talking about geometric series. They don't want you just using that formula. They want you figuring it out, because it is quite useful to see and do. So the start of the next month, he adds in another A amount. At the end of the second month, he has, he has this amount, but it gets bigger. So this becomes A 1.0011 multiplied by 1.0011. It gets bigger. So we square this one. This one gets bigger. This A amount gets bigger by 1.0011 amount. And this stays happening. The end of the third month would be A times 1.0011 to the power 3. He'd have this amount will get bigger. A times 1.0011 to the power 2. He would have added in an extra A, and it would have got bigger. It'd be 1.0011. And this stays going on. We're only at the end of the third month. This stays going on all the way down to the 36th month. Let's put in the 36th one over here. Let me change pens. The 36th month, the end of the 36th month would look like this. He would have, how many terms did he want? Include the first 2 and the last 2. Okay. He would have an A amount from his very first month, and it would instead getting bigger and bigger for 36 months. He'd have an A amount from his second month, and it would have got bigger every month for a total of 35 of them. And this would stay going on. I'll continue it on this line. He'd have the 36 months, he'd have 33 months, and so on. But then the last 2 terms would be, he'd have an A amount that's only been there for 2 months, and he'd have, in the very last month, the 36 months, in the start of the very last one, he would have put A in, and it would have got a little bigger, 0011. And this would be the total amount he'd have at the end of 36 months. This is the geometric progression they wanted you to show. And that'd be it. That'd be the full answer to this question. You could, if you want, take A out of everything and put a big bracket around this same thing here, a term plus a term. So that looks like a 0, I guess. Let's put a box. a term plus lots of other terms. You can write all this again with an A outside. So all these A's would disappear. If you want, both of these would be perfectly fine. And then part 2 of this question, they want you to obviously find A to solve this question. Because this is a geometric sequence here, or series, because there's pluses in between them, we have formulas for that. Let me jot down the formula. So we could add all of these up if we want, using the formula Sn is equal A multiplied by 1 minus or to the power of n over 1 minus or. The only thing we need to know is what's A, what's or, and what's n in this. A is the first term, and you could say this is the first term and this is the last, or you could do it backwards if you want. You just have to be a little careful. If this is the first term, the ratio is going to be 1 divided by this number that's in the bracket. If this is the first term, the ratio is going to be, well, the same number actually, as it happens. N, either way, n will be how many terms there are, and there's 36 of them. Okay, so in my case, I'm going to say A is this last one here. Instead of first, just rewrite it again if you want, in your head at least. So the first term is 1.0011. Or again, you could have A here as well. You could have the big A, but I'm going to use this idea. I'm going to take A out of all of them, and I'm going to write them the other way around. So the first term would just be this guy without the A. Hopefully that's clear. Yeah, honours level student, hopefully that is clear for you guys. Or, what is or? Again, or could be, in this case, or would be 1.0011. Let me write another possibility over here. Another possibility would be A being 1.0011 to the power of 36. Again, with big A or without it. And then or in this case would have to be, it's getting smaller every time, it's dividing. Or would be 1 over 1.0011. This would be a perfectly okay way to do it. Either way, n would be 36. I'm going to use this one, but again, you could use either one you want. Filling those numbers in here would get s to the power of 36 is equal, yeah, there's no point putting any of this down on the board. We're just filling these 3 numbers into this formula here. Your calculator will do it all if you're very careful, and you can do it a bit slower if you want. The final outcome will be, yeah, if I did just put this in, the final outcome would actually be 36.74209 and so on down. Be a little careful of that, because that's not the full answer. In this case, I've left A outside. Well, so this is a perfectly okay answer. But remember, A was here. All of this does equal 12,000. So clearly 36 doesn't equal 12,000. It's actually this number here multiplied by A is equal to 12,000. So A is just 12,000 divided by this number. Let's squeeze it in down here. A is equal to €326.60. Again, always do the common sense test on a question. If you put €326 into a bank for 36 months, multiply that by 36, you would actually get somewhere around 11,000 something, and then with all the extra interest, you get to 12,000. Yeah, okay, hopefully that answers that part of the question. I do just want to say, my main job is investing and stuff, so I deal in percentages all the time. As a student, you might say, if I put 300 a month into an account, I only get 12,000. Whereas if I put it under my mattress, I think the number is something like 11,500, say. It's not much of a reward. That's because this interest rate is tiny. In real life, if you were to invest in some general stock market, nothing risky, just like a general pension fund or something like that, you would often get like 7-8% a year, which again, this is less than 2% a year. So that number would, do this question again with a bigger percentage. You'll see, and instead of doing it for 3 years, do it for 30 years. You guys are young. You'll see just how much money you would make by simple saving and investing. Okay, let me clean this off and we'll do the next part. In part E, we're given this table here. I've took the liberty to change this middle bit. They say €5 less than the adult ticket. The adult ticket is X, €5 less than X is X minus 5. So that's the only change I've made here. To explain this table, we have a child will pay €11, and of all the tickets they sell, 52% of the tickets are children tickets. Again, student will pay this much, X minus 5, and 15% are students, 33% are adults, and they pay X amount. They also tell us the expected value of one ticket is 13.85. They want us to work out the value of X here. I'm going to use a little trick here that I found students, help some students. If you don't need help, you're probably not watching this part, but some students are confused by expected value. So let me first explain it, then I'll tell you the trick that we'll get around it by. So the expected value is, if you told me, I've sold a ticket, I know all this information, I've sold one ticket, but you're not going to give me any more information, I would use this number, expected value. If you told me I sold a ticket to a child, I'll use €11. If you told me I sold a ticket to an adult, I'll use whatever that number turns out to be. The expected value is what I would use without any of that knowledge. And we get that by getting 52% or 0.52 of this number plus 15% or 0.15 of this number plus that. That's how we get the expected value. Now forget that. A much easier way I find students like it is, imagine we sell 100 tickets. This is the value of one ticket, expected value. 100 tickets would be 1,385. We also know 52 out of 100 tickets are children. So hopefully this will make more sense. €11 multiplied by 52 is how much I sold the children tickets for. Plus X minus 5, I don't know the number yet, but multiplied by 15 of these tickets. Plus I sell 33 of these tickets. And all that adds up to 1,385. I find students just find this easier to deal in when I multiply everything by a big number. But I do want to say, I could have had 13.8 here. I just need to change this to 0.33. I need to change this to 0.15, and I need to change this to 0.52. Another thing I could have done is I've multiplied everything by 100 here. I could have multiplied by 1,000, by 200, by 587, any number I want. But I find 100 works best for most people. This is just an equation with one unknown. This is just a ordinary level, a junior cert even level question. Just solve for X. So I'll do it quite quickly. We have 15 X's here. We have 33 X's here. That gives me 48 X's. On the right side I have 1,385. Take away 11 minus 11 52s, and then minus 5 15s, so plus 5 15s. This will end up with 48x is equal to, let me just check my notes, 888, which is x is equal to, divide this across, x is equal to 18.5. Make sure this makes sense in your head. 1850 for an adult ticket when the child's ticket was 11. Yeah, that makes sense. The final part, part F, tells us about a little how business works. They explain what a markup is. A markup is the profit as a percentage of the cost price, and then they say what margin is. Margin is the profit as a percentage of the selling price. They tell us a shop sells an item with a margin of 18%. Work out the markup. Okay. What I find helps here is, you can do this question with no more information, But what I find helps a lot for a student is to make up. If they don't give you enough information, make up something. In this case, let's make up a product. We'll say a pair of shoes. And we'll make up a number. Again, we'll give ourselves a nice easy number to deal with, €100. So we'll say €100. That's how much these shoes are. You're going to buy them for. And they tell us the margin's 18%. So going back, the margin is the profit as a percentage of the selling price. So the profit this shop made, let's say it's X, divided by the selling price, 100. You made this number up, but it's fine. And that equals 18%, 1.8. So that means X equals €18. So this shop sells shoes for for €100. They make a profit of €18. So what was their cost price? Their cost price must have been 82. We can then work out what the markup is, because they tell us the markup is the profit divided by the cost price. So the markup is 18 divided by 82, which works out to be to the nearest percentage, 22%. And that's the full answer. If you're a little worried about the number, make up a new number. Let's see, I've done another one here. Maybe a games console that's €379. The profit would still be X divided by 379, which would equal 18%. So that means the profit would equal €68 this time. And that means the cost price, the shop sells it for this, they made this profit, so they must have bought it for 310.78. That means the markup is 68.22 divided by 310.78, which again equals 22%. And you don't have to make up a number. You could make up a number of Y, and the Y's would cancel. Still, should work out for everything. Okay, hopefully that answers all this question. You can probably hear in the background my baby crying, so I better get to that quickly. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a good day.